Good morning. It's August 28th, and this is your daily brief in science. Here's everything you need to know. Recent research is shedding light on innovative materials that could revolutionize food packaging. Specifically, GG-based films and coatings are being recognized as eco-friendly alternatives to traditional petrochemical plastics. Starch is emerging as a leading contender in the bioplastic market, primarily due to its biodegradability and sustainability. The study highlights the effectiveness of starch-based films for use as lids or components in food packaging, which could significantly contribute to waste reduction. Moreover, incorporating coffee silver skin into bioplastics has been shown to enhance tensile strength and Young's modulus. However, this inclusion does reduce elongation at break due to hydrogen bond formation. Measurements of water absorption and swelling indicate that coffee silver skin also affects the moisture resistance of these films. The research further evaluated the frozen storage of both untreated and optimally treated samples at various temperatures, assessing their quality retention. Notably, coated tomatoes exhibited better maintenance of firmness and weight compared to uncoated tomatoes stored in PET, which experienced significant quality decline. In addition to food packaging, the review discusses advancements in the application of gels in electronic devices, detailing their mechanisms and future potential. A new dual-mode flexible sensor has been developed, noted for its simple and environmentally friendly manufacturing process, indicating a shift towards sustainable technology. This sensor shows significant potential applications in smart wearable electronics and artificial electroskins, thanks to its impressive performance characteristics. Electrochemical performance tests reveal that lithium-ion batteries using BM/PiU2 retain 94.4% of capacity after 80 cycles. The sensor's ability to generate opposing response signals to strain and magnetic stimulation allows for real-time differentiation of various stimuli. A recent study sheds light on the vegetation net primary productivity, or NPP, in the Yellow River Basin, underscoring its vital role in green development and human well-being. This research delves into the gross primary productivity, GPP, of China's terrestrial ecosystems, analyzing its spatial and temporal dynamics from 1982 to 2018 through remote sensing and ecosystem models. The findings reveal that the scale of impact from various factors on NPP changes significantly over time, with relative humidity playing a major role due to the arid climate of the Yellow River Basin. The average net ecosystem productivity in the area was recorded at 289 grams of carbon per square meter per year, indicating a clear growth trend over the years. Utilizing normalized difference vegetation index data, the study highlighted that 90.1% of the Yellow River Basin experienced an increase in NDV1 from 2000 to 2022, with an overall trend of 0.032 per decade. The Yellow River Basin is crucial for China's economy, contributing 13.26% to the GDP. But it faces significant challenges, including severe water scarcity and rising demands for water, energy, and food. These challenges have sparked government initiatives aimed at ecological protection and sustainable development in the basin. The research also noted that precipitation and NDV1 significantly impacted evapotranspiration changes across the continental United States, emphasizing the interconnectedness of climate factors. The study highlights the necessity for accurate evapotranspiration estimation to effectively manage water resources, conserve forests, and respond to climate change. Urbanization has intensified drought conditions, particularly in central regions like Xi'an and the Loess Plateau, adversely affecting vegetation growth. Ultimately, the study aims to equip policymakers with quantitative insights for ecological conservation in the Yellow River Basin, guiding tailored policy combinations that enhance ecological protection and promote high-quality development. Mushrooms are emerging as a powerful ally in the quest for better health, boasting a range of beneficial properties. Recent research highlights their antioxidant, anti-inflammatory, anti-cancer, and immunomodulatory effects, making them a focal point in health discussions. A study led by Izabela Boleslawska and colleagues examined the bioactive components of 4 mushroom species: Alluria aurantia, Phallus hedriani, Phanis concatus, and Geostrum pectinatum. Utilizing advanced techniques such as gas chromatography, mass spectrometry, and thermogravimetric analysis, the researchers assessed the polyphenol content and other vital constituents in these mushrooms. The study's findings revealed significant variations in the bioactive compounds among the species, including beneficial fatty acids. All mushrooms analyzed contained polyphenols and essential minerals like calcium, magnesium, iron, and zinc, contributing to their health-promoting attributes. While exhibiting notable antioxidant activity, tests confirmed that the levels of heavy metals like lead and cadmium were within permissible limits. This reinforces the potential of mushrooms as sources of novel anti-cancer compounds, particularly relevant as traditional cancer therapies encounter limitations. Mushrooms, especially varieties like reishi and turkey tail, are gaining traction in the wellness market for their immune-boosting properties. The research suggests that these mushrooms could play a crucial role in developing health-promoting foods, nutraceuticals, or dietary supplements, appealing to health-conscious consumers. Recent research has shed light on the promising therapeutic potential of chimeric antigen receptor, or CAR-T cells, in treating nervous system tumors. A review by Ugo Testa, Germana Castelli, and Elvira Pelosi emphasizes the importance of novel CAR-T cell approaches in enhancing treatment effectiveness, particularly against solid tumors like brain cancers, which have been notoriously difficult to treat. High-risk neuroblastoma, an aggressive pediatric solid tumor, presents specific cell surface antigens such as GPC2 and GD2. These antigens make neuroblastoma a prime target for innovative CAR-T therapies. The tumor microenvironment in neuroblastoma is characterized by CD16A, expressing innate immune cells, which may influence the efficacy of CAR-T treatments. Research is underway to engineer T cells that express a GPC2-directed CAR, while also secreting a bispecific innate immune cell engager, or BiCE, targeting both GPC2 and GD2. Initial findings have shown promise with GD2 CAR-T cells in treating diffuse midline gliomas and neuroblastomas, along with CAR-V3-TE-AME cells for glioblastomas. Ongoing clinical trials are focusing on HER2 and EGFRV3, III-targeted CAR-T therapies specifically for patients with brain tumors. The review also highlights the need for innovative delivery methods, such as locoregional infusion, to improve CAR-T cell access to brain tumors. Currently, FDA-approved CAR-T products are predominantly for relapsed or refractory B-cell malignancies, but clinical trials are exploring their potential in solid tumors. Notably, advancements in the manufacturing process for autologous CAR-T cells have reduced the typical production time from about 2 weeks to as little as 2 to 3 days. Porcine reproductive and respiratory syndrome, or PRRS, is a significant concern for the global pig industry, causing substantial economic losses. The disease is triggered by the PRRS virus, which has 2 main genotypes: European, known as type 1, and North American, referred to as type 2. Each genotype has distinct genomic characteristics, complicating efforts to manage outbreaks. Adding to this complexity is the ongoing emergence of recombinant PRRSV strains, which challenge existing prevention and control measures. A recent study has shed light on the mechanisms of PRRSV pathogenesis, focusing on miRNA interactions. Specifically, researchers have identified LET7F5P as a potential target for antiviral therapies. This miRNA directly influences the lipid metabolism regulator SREBP2, which in turn affects the expression of genes involved in lipogenesis. Transcriptomy analysis of cells infected with PRRSV has revealed 1,718 differentially expressed genes, predominantly linked to lipid metabolism. Understanding the interactions between PRRSV and its host is crucial for developing effective antiviral strategies. Previous studies have shown that MIR2911 can inhibit infections from both influenza virus and SARS-CoV-2. Experimental results have confirmed that MIR2911 significantly reduces PRRSV replication, with target sequence analysis indicating a high level of conservation across different PRRSV strains. 6 specific target regions within the ORF1 gene have been identified as being targeted by MIR2911, highlighting its potential as a therapeutic target. This research was conducted by a collaborative team from multiple institutions in China, including Shihezi University, and was published in the journal Vet. See in August 2024. The findings represent a significant step forward in understanding PRRSV and developing targeted antiviral strategies. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.